This lesson I want to review the Lewis structure and how that relates to ionic bonds. So if you look at your handout, you notice the very last one, 2C, talks about lithium and nitrogen. And again, as a review, remember when you're doing Lewis structures, you're organizing the valence electrons, so the outer shell's electrons, and you find those on the periodic table. So we know, for example, that lithium being in the first column, being an alkali metal, has one valence electron. And so we place that on the north side of lithium. Nitrogen, which is in group 5, has 5 valence electrons. So we start by having one valence electron at the top, one at the bottom, and then one at the right. And it makes no difference if it's right or left, one on the left. So that gives me 4 electrons. And then I'm going to place one last electron on the top to equal 5 electrons. Remember, nitrogen has 5 electrons in the valence shell. And as I mentioned in class, if you have a pair of electrons in one of those poles, remember there's no possible way to bond. So nitrogen can't bond here, but it can bond here, here, and here. And we see that we have lithium that offers one electron that it can bond to. So we'll change colors here and just show how that might actually look. So this lithium electron, we'll put a little circle around it, very likely is going to lose its electron and give it to nitrogen. Now that means that lithium has a +1 charge, and nitrogen, having just gained one more electron, has a -1 charge. Okay, so that takes care of this pole, which has 2 electrons, and this pole, which has 2 electrons. But you notice there's still these 2 ends of nitrogen that don't have electrons, or better said, there are no electron pairs. And so it doesn't have its valence shell of 8 that it wants to have. So what can it do? Well, what it tries to do is to get those electrons from substances, and so for that reason you would need to have 2 more lithiums so that it can fill that valence shell. And so here is lithium that we have. Okay, and so yes, you are able to add lithiums just randomly. And using our red marker, we'll draw our electrons. So remember, lithium has 1. So if we give nitrogen 3 lithiums, we should actually be able to have those lithiums lose those electrons. One is going to be lost from this lithium, this one right here, and the other electron will be lost from this lithium and be released right over here. That now nitrogen has 8 electrons. So how would you write this as a chemical formula? Remember, the chemical formula tells you how many atoms you have of each type. So to start off with, we know we have lithium. So that's one type of element we have. And we know we have nitrogen. So now we need to do a count. How many lithiums do we have? We have 1, 2, and 3. So that means that we have 3 lithiums, which is what we put as our subscript. And how many nitrogens do we have? We only have 1. And so we don't put a subscript down at all. And so the chemical formula for lithium and nitrogen is Li3N. So the nice thing about Lewis structures is you can always predict what that chemical formula is based on the electrons and what it needs to get its complete valence shell. So now for homework, I'd like you to try some of these Lewis structures, just as I did here, and the chemical formula on the bottom on a sheet of binder paper. The first one you'll be doing is aluminum and chlorine. And please have this on the binder paper because I will take a look at your work. The next one you're going to be doing is calcium and chlorine. And the last one you'll be doing is lithium and oxygen. Please draw the Lewis structures, use arrows to show where the electrons go to, and then do a proper chemical formula. Remember, you can add as many of each element as you need to in order to fill those valence shells.